Now the next topic, consistency of system of linear equations. By rank method or in rank method we are using elementary transformation method. What does it mean consistent? Consider two lines in a plane. If we consider two lines in a plane, it may be in three different ways. One, intersecting. They are intersecting. Two, they are coincident. Three, they are parallel or distinct. Parallel or distinct. If we consider three lines in a plane, they will be either intersecting line or coincident line or parallel line. Now, diagrammatically I am representing here. There are two lines. Let it be line 1 and another one be line 2. They are intersecting. They are intersecting at a single point. This is intersecting at a unique point, single point. Here, the coincident line. Suppose two lines, one form other. This is line 1 and the second line form on this first line. These type of lines are coincident lines. If the first line starts from here, this is L1, and second line starts from here, L2. Both coincide from here. These lines are known as coincident lines. And the third one, parallel or distinct. They are parallel, L1 and L2. They are known as parallel or distinct lines. We consider three lines in a plane. They will be one intersecting or coincident and parallel or distinct. Okay. They are intersecting. The first case, both lines intersect at a single point. Therefore, there is a unique solution occurs here. A unique solution. The first case we can get a unique solution. Solution means is nothing but a common point lies on both the lines. That is, this intersection point is known as a solution of this point. It has unique solution because both intersect at a single point. Therefore, these two lines has a unique solution. Right. The coincident line. Coincident line means what? One line forms on the other line. So each and every point after the intersection, each and every point on the lines are the solutions. So these coincident line can have infinitely many solutions or more than one solution. You can write or more than one solution or infinitely many solutions. It may have more than one solution or infinitely many solutions. Coincident line can have more than one solution or infinitely many solutions. Infinitely many solutions. The third case, parallel or distinct. There is no common point between these two lines. Therefore, these two lines have no solution. It has no solution. So, if we consider two lines in a plane, either they are intersecting or coincident or parallel or distinct. These are basic things to learn about the consistency. Now, what does mean consistent? These two type of system of equations, line 1 and line 2 represents two system of equations. Okay, they are two system of equations. line 1 and 2 represents two system of equations. Here case 1 and 2 is consistent. Case 1 and 2 are known as consistent. The case 3 is known as inconsistent. Case 3 is known as inconsistent. Why? So, consistent means solution must exist. It may be a unique solution or infinitely many solutions. If a system of equations, if system of linear equations has a unique solution or infinitely many solutions, those system of equations are known as consistent. If the system of equations has no solution, those system of equations are known as inconsistent. This is a very basic thing. If solution exists, the system of equations are consistent. If solution does not exist, the system of equations are known as inconsistent. When solution exists, it will happen in two different ways. The first thing is there may be a unique solution, only one solution will exist, or more than one solution, that is known as infinitely many solutions will exist. If solution exists, there are two different ways. If solution exists, those system of equations only called as consistent system of equations. Okay. Now, if solution does not exist, that is no solution, the system of equations is known as inconsistent. Consider two system of equations, two system of linear equations. a1x plus b1y equal to c1 and a2x plus b2y equal to c2 are two system of linear equations. Then comparing the coefficients, the coefficient of x1 is a1, here x1 is coefficient of x is a2. Coefficient of x is here a1, coefficient of x is a2. In the first line, coefficient of y is b1, and the second line coefficient of y is b2. And the constant term is here c1 and there c2. Or we can take the equations like this: a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Any of the way we can keep the equations. Now, by the coefficients itself, finding the ratios, we can conclude the given system of equations is consistent or not. Now, first case, a1 by a2 is not equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, these two system of equations can have a unique solution. Suppose a1 by a2 equal to b1 by b2, that is also equal to c1 by c2. Comparing the coefficients, finding the ratios. Suppose if it follows the second case, a1 by a2 equal to b1 by b2 equal to c1 by c2, these two system of equations will follow infinitely many solutions. And third case, a1 by a2 will be equal to b1 by b2 but not equal to c1 by c2. These typical cases, these two system of equations has no solution because it will be parallel. The first one is intersecting at a single point. The second one follows intersecting at many points. There may be a coincident line. Then the third one is parallel line. Consistent means we should have a solution. We should have solution that is a unique or infinitely many solution. Therefore, the two system of equations is known as consistent. It may follow a unique solution or infinitely many solution. Suppose these two follows the third case, it has no solution. The system is known as inconsistent. The next case is consistency of system of non-homogeneous equations in three variables. Consistency of system of non-homogeneous equations in three variables. Already we have learned consistency of system of equations in two variables. Now this is three variables. For three variables, consider three system of equations: a1x plus b1y plus c1z equal to d1, and a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. And the coefficient of x, y, z are all non-zero. a1, b1, c1 all should be non-zero, or a2, b2, c2 are all non-zero, or a3, b3, c3 are all non-zero. At least one of the coefficients is non-zero in the given three equations. Okay, must be non-zero. The system of non-homogeneous equations. What is the difference between non-homogeneous and homogeneous? If the constant terms, the right side constant terms d1, d2, d3 are all zero, if the constant terms of the given system of equations are all zero, then the system of equations is known as homogeneous. Homogeneous is nothing but the system of equations are all the constant terms of the given system of equations are zero. All the constants are zero. The system of equations is known as homogeneous. If at least one constant is non-zero in the system of given equations, that is known as non-homogeneous system of equations. Right. Consider three non-homogeneous system of equations like this way. In that the coefficients of x, y, z are all not zero. Are all not zero means at least one coefficient must exist. Okay. Then how to find these system of equations are consistent? For that we have some ideas. Right. First of all, we should convert the given system of equations into matrix form. That is, the conversion of matrix form is a1, b1, c1, a2, b2, c2, a3, b3, c3 into xyz equal to d1, d2, d3. The first one is known as coefficient matrix, second one is the corresponding variable matrix, the third one is the constant matrix. When we multiply these two matrices, we will get the left side of a1x plus b1y plus c1z, and like this way, and the constant terms will, when equating, you will get these three equations. So now I am converted here the given system of equations into matrix equation. Now this is in the form of ax is equal to b. We have learned already in 11th standard how to find the solution. X is equal to a inverse b. That is in 11th standard. The system of equations rewritten in the matrix form as ax is equal to b. Now, augmented matrix. Augmented matrix. Augmented matrix AB is known as, just joining the matrix A and B is known as augmented matrix. That is equal to AB. Augmented matrix AB equal to, combine these two matrices and form a new matrix, that is known as augmented matrix. Combine, what are they combined here? A and B are combined. The combine A and B form a new matrix A1, B1, C1 and D1. A2, B2, C2, D2, A3, B3, C3 and D3. This is known as augmented matrix. Augmented is nothing but combination of A and B. We are forming a new matrix by using the matrix A and B. That is known as augmented matrix. Now, after forming augmented matrix, we can apply elementary transformation in it. Elementary transformations. What are the elementary transformation? First one. What are the elementary transformation? First one is interchange of any two rows or columns. Second one, multiplication of a row or column by a non-zero constant k. Third one, addition of a row or column with some other row or column. That is the third thing. These are the elementary transformations will be applied here. After applying elementary transformation, we may have echelon form. In that echelon form, we have different categories. They are discussed here. The augmented matrix AB is A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. Apply elementary transformation in it. After applying elementary transformations, we may have these four type of equivalent matrices. Any one will arise. Not all at the same time. Any one of the equivalent matrix will arise. Okay. After getting this equivalent matrix, they are in echelon form. We can consider rank. How to consider the rank of these four matrices? First, you should find the rank of A. Then you can move to rank of AB. Rank of A. To find rank of A, close the last column. Then count the number of non-zero rows. If we close the last column, there are 3 rows here. They represents A, matrix A. Now the rank of A is nothing but here non-zero row, here also non-zero row, here one non-zero row. There are 3 non-zero rows. Therefore the rank of A is equal to 3. And now include the last column in the matrix. Now this represents AB. If we add the last column in it, it represents AB. When we close the last column, the 3 rows and columns represents matrix A. When we add the last column, it represents AB. Now find the rank. Now rank of AB. This means how many non-zero rows occurs? All are non-zero rows. Rank of AB is also 3. Similar to that, suppose these type of equivalent matrix arise. Rank of A is equal to, close the last column again. Here 1 0 row, 2 non-zero rows. Therefore rank of A equal to 2. Now include last column. Rank of AB equal to, all are non-zero rows. Rank of AB equal to 3. Now third type of equivalent matrix suppose arise. Now find the rank of A. Here 2 0 row, only one non-zero row. Therefore rank of A is equal to 1. Now rank of AB. To find rank of AB, include the fourth column. Here 1 0 row, 2 non-zero rows. Therefore the non-zero rows only counted in the rank. Therefore rank of AB equal to 2. And then the fourth type, there are, close the last column. Here 2 0 rows and 1 non-zero row. Therefore rank of A equal to 1. Rank of AB, include the last column. Now find the rank. Now rank of AB is also same. Here we have 3 typical cases. The first one is rank of A equal to rank of AB. Case 1, rank of A equal to rank of AB. Case 2, rank of A is equal to rank of A equal to rank of AB. And case 3, rank of A is not equal to rank of AB. I have written twice here because of some purpose. Look at the first equivalent matrix. Here rank of A equal to rank of AB, and the rank also equal here. Rank of A equal to rank of AB equal to 3. This is the first case. Okay. And then here rank of A equal to rank of AB, that is equal to 1. And then here rank of A is not equal to rank of AB. And one more case will arrive. Rank of A equal to rank of AB equal to 2. Rank of A equal to rank of AB equal to 2. One another case will arrive. Now this is the first case. Rank of A equal to rank of AB equal to 3. 3 represents here the number of unknowns in the given system of equations. What are the unknowns here? We have a1x plus b1y plus c1z equal to d1. In that case, x, y, z are all known as unknowns. Okay. So in 3 by 3 system of equations given, x, y, z are known as unknowns. Now the unknowns represents 3. So rank of A equal to rank of AB, which will be equal to number of unknowns, the first case. These two represents the second case. What are they? Rank of A will be equal to rank of AB, but not equal to 3. The first case is equal to number of unknowns. The second case not equal to number of unknowns, that will be represented by less than number of unknowns. Less than number of unknowns. That is represented by less than number of unknowns. Rank of A will be equal to rank of AB, that will be equal to 3, that equal to 3, that is equal to number of unknowns. Here rank of A equal to rank of AB, here also rank of A equal to rank of AB, but these two represents less than number of unknowns. The third case is rank of A is not equal to rank of AB. That means either 2, 3 or 1, 2 in the same manner. Okay. Now, what is the difference between these three cases? How to we can associate the consistency to the three conditions. Okay, we can conclude the consistency now. There are three cases. One is rank of A equal to rank of AB equal to 3, equal number of unknowns. Second case is rank of A will be equal to rank of AB but less than number of unknowns. The third case is rank of A is not equal to rank of AB. X, Y, Z are known as unknowns. If rank of A equal to rank of AB, that will be equal to given number of unknowns. The system is consistent and has unique solution. The second case, if rank of A equal to rank of AB but less than number of unknowns, like this way, the system is consistent but it have infinite number of solutions. The third case, rank of A not equal to rank of AB, the system has no solution, it is known as inconsistent. These are the ways to check the consistency of three non-homogeneous system of equations. So every system of equations can have a unique solution or infinitely many solution or no solution. First we have discussed about lines a1x plus b1y equal to c1, a2x, b2y equal to c2. These system of equations represents system of lines. Now there are three variable equations, three variable linear equation. a1x, b1y, c1 is that equal to d1, a2x, b2y, c2 is that equal to d2, and a3x, b3y, c3 is that equal to d3. These three equations represents three different planes. Three different planes. These are three dimensional, they are representing planes. These are two dimensional, they are representing lines. We are entering into a problem. Question number 3 in our exercise 1.1. Solve the system of equations x plus y plus z equal to 9, 2x plus 5y plus 7z equal to 52, 2x minus y minus z equal to 0 by rank method. In question itself, they have given by rank method. When performing consistency by rank method, you should perform only row operations. Do not apply column operations. If you apply column operations, your answer will not be correct. So, just perform only row operations. First, write the given system of equations into matrix equation. The corresponding matrix equation is coefficient matrix and variable matrix and equal to constant matrix. Variable matrix 1 1 1. This is constant matrix. The constants of x, y, z are 1. Coefficient matrix. Then second equation we have coefficients 2 5 7. And third equation we have coefficients 2 minus 1 minus 1. 2 minus 1 minus 1. The coefficient of first equations are coefficient of x, y, z's coefficients are written in the first row from the first equation. The 1 1 1 first row, 2 5 7 in the second row, 2 minus 1 minus 1 in the third row. Then the variable matrix. What are the variable used here? X, y, z, which will be equal to the constant matrix 9 52 0. You should write in a proper order. Okay. Now this is in the form of A x is equal to B. Let the coefficient matrix as A and the variable matrix as x and the constant matrix as B. Now form augmented matrix. Augmented matrix. AB. Augmented is nothing but just joining the matrix A and B, forming a new matrix. That is AB equal to, augmented matrix AB will be equal to 1 1 1 9, 2 5 7 52 and 2 minus 1 minus 1 0. This is the augmented matrix. Now we are going to apply elementary transformations to form echelon form. The first entry to make 0 is this 2. For that, multiply the first row by 2 and subtract. This is equivalent to R3. Now I am forming R3 here. That is performed by using the R3 and the R1 of the previous matrix. R3 tends to R3 minus 2R1. Because we have 2 here, when multiplied by 2, it will become 2. 2 minus 2 becomes 0. For that purpose, I am multiplying R1 by 2. Perform the operation here. R3 minus 2R1. R3 is 2 minus 1 minus 1 0. And 2R1. 2 2 2 18. Subtract. How 0 minus 3 minus 3 minus 18. Apply in the third row. 0 minus 3 minus 3 minus 18. For second. Now we are given priority to make this number at 0. Here also we have 2. So multiply again R1 by 2 and subtract from R2. So the new R2 formed R2 minus 2R1, formed by the operation R2 minus 2R1. Again here R2 minus 2R1. R2 gives 2 5 7 52 and multiply R1 by 2. Again 2 2 2 and 18. Subtract. When we subtract, will get 0, 3, 5, 52 minus 18, 34. 52 minus 18, 34. Now write these entries in R2, 0, 3, 5, 34. There is no change in the first row. Keep the same elements in the first row. Now look at the second equivalent matrix. This is the first equivalent matrix. Look at the second matrix. Here 0, 0, 3 minus 3, 5 minus 3, 34 minus 18. We should make this minus 3 as 0 next. For that, just adding these two rows, 0 plus 0, 0, minus 3 plus 3 becomes 0. So this entry will be 0 when we are adding R3 with R2, so that forming a new matrix here is equivalent to R3 tends to R3 plus R2. This means adding these two, 0, minus 3 plus 3, 0, minus 3 plus 5, 2, minus 18 plus 34. 34 minus 18, which is equal to 16. 0, 0 to 16. Our next move is to make this 3 as 0. Our next move is make this 3 as 0. Listen, if we try to form this 3 as 0, we should multiply the row 1 by 3 and subtract from R2. If it happens, this 3 becomes 0, but this 0 becomes minus 3, because while multiplying, the R1 changes to 3, 3, 3 and 27. When subtract from here R2 to R1, this element can become minus 3 and this one becomes 0. But already I told you, the echelon form should not be affected. So you can leave the second row as it is, 0, 3, 5, 34, and no changes in the first row, 1, 1, 1, 9. Now look at the second equivalent matrix. In this matrix we have a echelon form, and if we proceed further to make this 0, this 0 entry will become non-zero. This indicates the problem is get over here, so you can stop here. This is the final required equivalent matrix. Now compare the rank of A. What is the rank of A? How to find the rank of A? Rank of A is equal to find rank of A, eliminate the fourth column, find rank. Here how many 0 row? No 0 row appears. Here one non-zero row, all are non-zero rows. Therefore rank of A is equal to 3. And now include the fourth column. Now find the rank. Now rank of AB equal to, here also all are, here 2 zeros, but these are non-zero entry. For all the given 3 rows in AB also non-zero, so it is rank also 3. This implies rank of A equal to rank of AB equal to 3, equal to number of unknowns. How many unknowns are there in the given equation? There are 3 unknowns. They are x, y, z. Rank of A equal to rank of AB, but equal to 3. That means the rank of the A and AB are equal, and that is equal to the given number of unknowns. This means the system is consistent and has unique solution. Okay, how to find the unique solution? To find the unique solution, just write the last equivalent matrix into matrix form. Write the last equivalent matrix into matrix form. That is the coefficient matrix, variable matrix, and is equal to the constant matrix. The way coefficient matrix are 1 1 1 0 3 5 0 0 2, and the variable matrix is always taken as x y z. Then the constant matrix is 9 34 16. Now we can form three different equations. The first one is 9x 1x, the first one is x plus y plus z. 1x plus 1y plus 1z, which will be equal to 9. And the second equation is 0x plus 3y plus 5z equal to 34. And the third equation is 0x plus 0y plus 2z equal to 16. These are the three equations formed. In the first equation we have x, y, z. The second equation, the coefficient of x is 0. Therefore we can omit it. You can simply write the second equation as 3y plus 5z equal to 34. The third equation we have only coefficient of z is non-zero. Other two equations are 0. We can leave it. So 0x and 0y left. Remaining is 2z equal to 16. From the final equation, last equation, we can find the value of z. 16 by 2. Bring it to here. 16 by 2 equal to 8. Divide 16 by 2, you will get the value of z. Now, substituting this z equal to 8 in the equation 2. Let it be equation number 1. Another one is 2. This one is 3. 3 implies z equal to 8. Substitute z equal to 8 in 2, which implies 3y plus 5 into z. 5 into 8, that means 5 into 8, 40 equal to 34. Now 3y equal to 34 minus 40 equal to minus 6, which implies y equal to minus 6 by 3 equal to minus 2. And now substituting the values of z equal to 8 and y equal to minus 2 in the first equation. First equation is x plus y plus z equal to 9. One implies x plus, instead y we have minus 2, x minus 2 plus z plus 8 equal to 9. Simplify, x plus 6 is equal to 9. Now x is equal to 9 minus 6 is equal to 3. Therefore x is equal to 3. Therefore the solution of the respective equations is x comma y comma z equal to 3 comma minus 2 comma 8. You can check your answers by substituting this x, y, z in the given equations. First three equations. All the equations should satisfy these values. These values should satisfy all the three equations. You can easily verify your answer. This is the idea to solve the given three system of non-homogeneous equations by rank method. Now question number 5. Show that the equations have a unique solution by rank method. Show that the equation have unique solution. Already they have given, we have to show the given equation has unique solution. For that, we have to prove rank of A equal to rank of AB equal to 3. Rank of A equal to rank of AB equal to 3 number of unknowns. Okay. Answer starts here. The corresponding matrix equation is coefficient matrix, variable matrix, constant matrix. The augmented matrix is a combined form of A and B. This is in the form of AX is equal to B. The combined form of A and B is augmented matrix. Here 1, 1, 3, 1, 2, 3, 4. Second row 1, 4, 9, 6 in the third row. Okay. To form echelon form, apply elementary transformations. First, you should make this entry as 0. For that, subtract this R3 with R1 or this R3 with R2. You can choose arbitrary rows. Any rows you can take, but the entry becomes 0. Now I am choosing R3 and R1. R3 minus R1 means 1 minus 1 0, 4 minus 1 3, then 9 minus 1 8, 6 minus 3 3. This is very simple calculation, so directly you can write. The numbers are because just work out at the right side and then write the answer. It will be more easy. Now, our next priority to make this element as 0 to form my echelon form, triangular form. So I am choosing again first row and second row. Subtract R2 from R1 from R2. R2 become R2 minus R1. 1 minus 1 0. 2 minus 1 1. 3 minus 1 2. 4 minus 3 1. There is no change in the first row. Just to keep the same values in the first row. Here, the next priority to do is the 3 becomes 0. To try to make this 3 as 0, look at the last two rows and multiply this entry by 3 and subtract. 3 minus 3 becomes 0. Already these two are 0, so it will not be affected. So you can follow that process. Now here the new R3 framed by using the R2 and R3 of the previous matrix. R3 tends to R3 minus 3R2. R3 minus 3R2. Multiply R2 by 3 and subtract from R3 of the previous matrix. We will get a new entries. 0 minus 0, 0, 3 and multiply it by 3. I will proceed here. R3. R3 means 0, 3, 8, 3. Then multiply R2 by 3. 0, 3, 6, 3. Subtracting. We will get 0, 0, minus, 2, 0. 0, 0, 2, 0. That is written here. 0, 0, 2, 0. Then now, if we want to make this entry as 0, because our target is to make this entry as 0, the next move. In the time, if we make this one as 0, this become non-zero, because to form this one as 0, we can subtract with R1. If we subtract with R1, 1 minus 1 0, but 0 minus 1 become minus 1. When we writing in the R2, this entry become non-zero, this entry becomes 0. But in our process, the triangular form should not be affected. So now this is a time to end the problem, because when we move to the next element to form a 0, the zeros already formed is turned as non-zero. So we can stop the process. So the last matrix is in echelon form. Here the number of non-zero rows is 1, 2, 3 for A, and adding the last column, now also rank of AB is also 3, 1, 2, 3. So rank of A is equal to 3 and rank of AB is also equal to 3. Rank of A equal to rank of AB equal to 3. How to calculate rank of A? Close the last column. Now count the rank. Count the non-zero rows. 1, 2, 3 non-zero rows are there. Therefore rank of A equal to 3. Now add the fourth column. Now this is the matrix AB. This is matrix A. Now this is matrix AB. The reduced matrix AB. After adding the fourth column. Now counting the non-zero rows, 1 non-zero row, second, third, there are 3 non-zero rows. Therefore, rank of AB is also 3. Here we have rank of A equal to rank of AB equal to 3. That is equal to number of unknowns. Number of unknowns. Number of unknowns. Unknowns is nothing but the variables x, y, z given in the equation. So this system, which implies system is consistent. System is consistent and has unique solution. And has unique solution. How to find that unique solution? To find the unique solution, write the last equivalent matrix in the matrix form. That is equal to coefficient matrix, variable matrix and a constant matrix. 1 1 1 0 1 2 0 0 2. This is the coefficient matrix, and the variable matrix x, y, z, that will be equal to the constant matrix 3 1 0. Now equating these equation, we will have 3 different equations like that. X plus y, which implies x plus y plus z, 1x 1y 1z equal to 3. And the second equation is 0x, we can omit it, 1y plus 2z, 1y plus 2z, 1y plus 2z equal to 1 in the second entry. For third case, 2z, 0x, 0y and 2z equal to 0, which implies z equal to 0. We have found one solution, z equal to 0, solution for z equal to 0. Now substituting z equal to 0 in this, we can get y equal to 1. Therefore z equal to 0, y equal to 1. Again substituting z, y in this equation, x is equal to x plus y become 1, z becomes 0. So x plus 1 plus 0 equal to 3, then x plus 1 equal to 3, then x is equal to 2. Therefore the solutions are x is equal to 2, y equal to 1 and z equal to 0. Substitute z equal to 0 in 2. This is equation number 1. This is equation number 2. Substitute z equal to 0 in equation number 2. We can have y plus 2 into 0 equal to 1, which implies y equal to 1. Then substitute z equal to 0, y equal to 1 in equation 1. We have x plus 1 plus 0 equal to 3, then x plus 1 equal to 3, which implies x is equal to 2. 3 minus 1 equal to 2. Therefore, solution, the unique solution is x comma y comma z equal to 2 comma 1 comma 0. This means the given 3 system of equations represents 3 different type of planes. These planes are intersecting at a single point. The planes are intersecting at a single point. This is the required solution. You can check your answers by substituting these values for x, y and z in the given 3 equations. All will yield the right side answer. In that case, your answer is correct. If any one of the equation is not satisfied, your solution will be wrong. You can check it yourself.